Hi, I'm Damien Key, and in this video we're going to be using this robot and a little bit of maths to calculate how far it can travel. When working with robots, we find they are generally very good at measuring how far their wheels turn. 6 rotations, 258 degrees and so on. While it's great to be able to tell the robot to turn its wheels a certain amount, often it's far handier to tell the robot how far we want it to travel in a straight line. This is what we call a linear distance. So what is the relationship between how far a wheel turns around and how far in a straight line the robot travels? Let's look at this particular example. Draw the ground there. I'm going to take this wheel and turn it so the marker is pointing down. This is our starting point. I'll put a mark just here where that wheel is starting. If this wheel turns around one complete rotation, that marker ends up there. This distance from where the marker started to where the marker finished is the distance the robot has travelled if the wheels turn around one complete rotation. This is also known as the circumference, or the distance around a wheel. So how do we calculate the circumference of a wheel? To calculate the circumference of a wheel, we'll need an equation. And the equation we use in this case is circumference is equal to pi times the diameter. We can take pi as 3.14, and in our case, with our wheel, it has a diameter of 56 millimeters. What this means is the circumference of this wheel is 176 millimeters. What that means is if this wheel turns around one complete rotation, our robot will drive forward 176 millimeters. So how do we use this information? Well, let's suppose we want our robot to drive in a straight line for a set distance. Let's choose, say, 500 millimeters. We know that one rotation is 176 millimeters, so we need to calculate how many rotations are needed to travel 500 millimeters. To do that, we will take 500 millimeters, divide it by 176 millimeters, which is the circumference of our wheel, and this gives us 2.84 rotations. What this means is, to make our robot drive forward 500 millimeters, we need our wheels to turn around exactly 2.84 rotations. Let's how we put this into a program.
Okay, so we're going to keep this program very simple. We're just going to use a single move block and get it to travel forward for 2.8 rotations, just like we calculated. So I'm going to start with grabbing a move block and drop it down on the grid space where it says start. Looking down here at our configuration panel, my robot is set up to use motors B and C. We're going to go in a forward direction. We're going to keep our steering in the middle there, making sure it goes straight. The power level is not going to affect how far our robot travels, so I'm just going to drag this down to 50%. Not too fast, not too slow. And the key thing we want to look at now is the duration. Now, we calculated for our robot to drive 500 millimeters, we needed the wheels to go around 2.84 rotations. After we finish our 2.84 rotations, we're then going to apply the brake. We'll then download this program to our robot and test to see how it goes.
So here we have set up two tape marks, exactly 500 millimeters apart, and our robot, in which we have programmed the wheels to turn around 2.84 rotations. Let's see how it goes. And as we see, 2.84 rotations of the wheels gives us exactly 500 millimeters.